For those who aren't familiar with ICL, our company is one of the largest specialty fertilizer companies, globally. It's around 100 years old, and one of our core competencies in specialty fertilizers is innovation and manufacturing of very high quality water soluble fertilizers. And so that is, the key topic that we're going to discuss today, and that's the application of water soluble fertilizers to early season nutrition, particularly for row crops. But we'll also talk about some examples from specialty crops like potatoes and tree fruits. So as I think about, spring 2025, planting operations across the Central Corn Belt will begin hopefully within the next 8 to 9 weeks. And in some areas, planting will begin even sooner than that. So we're certainly at a point where early season plant nutrition for starter fertilizer in particular is becoming something that's already in place for many growers, or potentially a strategy that's still being considered for spring 2025. And so today we want to talk about innovative starter strategies and particularly water-soluble fertilizers. We'll talk a little bit more about what are water-soluble fertilizers and some key examples from our research trials that we've led across the United States and various crops over the last few years, specifically looking at an innovative ICL water-soluble fertilizer called PEC acid and some of the derivatives of PEC acid. With water-soluble fertilizers, we have the opportunity for superior precision in nutrient blends, thinking about the range of different water-soluble fertilizers that are available. And then, of course, with in-furrow application and 2x2 application at planting, that's also a way to precisely apply nutrients close to where that developing plant needs that early season nutrition. In our conversation around PEC acid, we're going to talk about enhanced nutrient availability, particularly for phosphorus, but also for other nutrients like micronutrients that are often influenced. Their availability is influenced by pH of the soil or the water in which they're being carried, and how that can impact crop growth. We'll have some examples of how pH modification impacts phosphorus use efficiency. We talked about precision agriculture applications, and really that ties back to the versatility and the broad diversity of water soluble fertilizers that are available, and how we can use those in different combinations to target specific soil types, soil pHs, and even thinking more broadly beyond early season nutrition, other application types like in-season foliar applications. And then lastly, as we think about nutrient use efficiency and specifically phosphorus use efficiency, that certainly has environmental benefits as well as economic benefits for both the retailer and the farmer. So when we think about water-soluble fertilizers, these are products that, as the name would imply, are very easy to solubilize in water and break down very quickly in water and become plant available. Some of the concepts illustrated here come from the world of fertigation, but we'll talk briefly about these and how they influence the choice of water-soluble fertilizers. First of all, we talk about considering water quality parameters, and certainly this is very important in fertigated markets across North America and globally. And these water quality parameters include pH, electrical conductivity, bicarbonate levels, and other factors. And so those underlying water quality parameters can influence the choice of acid-forming versus non-acid-forming water-soluble fertilizers. Also within the fertigated market, and even within the row crop starter fertilizer examples that we'll talk about today, salt index is a very important parameter that should be considered, as well as the absence of chloride coming from common fertilizer ingredients like potassium chloride or potash. The salt index and chloride level influences seed safety or root safety, particularly when we think about seed placement or banded fertility early in the season. Water-soluble fertilizers can vary widely in their solubility, or the number of pounds that can be dissolved per gallon of water, which influences the concentration level of nutrients that can be supplied per volume. Compatibility with other water-soluble fertilizers or liquid fertilizer sources, and this is especially relevant to the interaction between calcium and phosphorus, whether that calcium is being supplied as a fertilizer, intentional fertilizer additive, or when we think about hard water and the calcium or magnesium that may naturally be present in that hard water. And then finally, water-soluble fertilizer choice can be influenced by the desired nutrient analysis or nutrient balance determined by the application timing for specific crops. Digging further into this interaction of water quality and nutrient source, again, there's some examples here that come from the the fertigation market and commonly recognized importance of water quality and how that can impact uniformity of water distribution through drip irrigation and other forms of micro irrigation. But when we think about using water-soluble fertilizers for a starter fertilizer application, as an example, the quality of the water in which we're dissolving that water-soluble fertilizer can certainly have an impact on the availability of the nutrients that we're trying to supply in those water-soluble fertilizers, especially if we're focused on phosphorus for those early season nutrition needs for crops like corn. Water-soluble fertilizers are very diverse, and there's many different options available throughout the water-soluble fertilizer industry. But these are just a few examples, and these are all examples of ICL water-soluble fertilizers. In the next section, Christi will talk more about Nova Pec Acid, which is a proprietary to ICL, innovative water-soluble phosphorus and potassium-containing fertilizer with an analysis of 0-60-20. Similarly, we have other phosphorus and potassium-containing water-soluble fertilizers like High Peak, slightly different analysis there of 0-44-44, and then monopotassium phosphate, or MKP, which many in the specialty fertilizer market will recognize with an analysis of 0-52-34. Once we get past these phosphorus and potassium only containing fertilizers, there are other examples like MagPhos, which again contains magnesium, phosphorus, and potassium, water-soluble potash, water-soluble MAP or monoammonium phosphate, magnesium nitrate, and potassium nitrate. So if you consider these examples, there's many different ways in which these can be combined to create novel or tailored fertilizer blends. And then also in the world of water-soluble fertilizers, there are so-called water-soluble NPK fertilizers, which combine multiple macronutrients, NP and K, along with, in many cases, micronutrients as well, to have a finished product that can be used for a broad range of applications, whether that be a starter, for fertigation, or in many cases also for foliar applications. Before I hand it off to Christi, again, these are three of ICL's key phosphorus and potassium containing fertilizers that are produced in different ways, using phosphoric acid and potassium sources. And so we have again MKP, monopotassium phosphate, 0-52-34, Pec Acid, 0-60-20, and High Peak, 0-44-44. And if you look at these three products, which are derived from very similar ingredients, they have very different characteristics in terms of pH and solubility. Monopotassium phosphate has a pH of around 4.5. Pec acid in solution has a pH between 1 and 2, so very acidic. And then High Peak has a neutral pH. When we consider solubility, monopotassium phosphate has a solubility of around 1.9 or 2 pounds per gallon, whereas Pec acid and High Peak are between 5 and 6 pounds per gallon, depending on the starting water quality. And so again, this speaks to the versatility of water-soluble fertilizers and the choices that are available, depending on what you're trying to accomplish from a crop and application perspective, but also some of the underlying water quality or soil chemistry characteristics you're trying to solve with your fertilizer choices. So with that introduction, I would invite Christi to dive a little bit more into Pec acid technology and set the stage for some of the trial data that we'll present here today.
Oh, awesome. So we can definitely utilize, as Jason has highlighted, some of the water-soluble fertilizers for starters and look at them for being side dress or banded applications, but also as far as fertigation. For us here in the West, we utilize fertigation a lot, whether we're talking through drip irrigation or through the pivots. And so the preciseness of them and trying to get it to where we're nailing it down tools, we definitely would like to do that. So let's start looking at a few examples. As Jason mentioned, the Nova Pec acid, we can start with that technology, and it is safe and can be put next to the seeds or the transplants. The huge benefit that we have of this technology is the acidification that happens as we acidify the pH in the root zone next to where the nutrients are being taken up, especially for our calcareous soils. Then we can get better phosphate, iron, manganese, and zinc for example, as far as better nutrient uptake because we have adjusted and done a precise application in the root zone. Or if you don't want to do straight PEC acid, we do have other options that we could do with our Agrolution pH low line. And we have a lot of different formulations with that Agrolution pH low line. And those would be containing the Nova PEC acid technology. So there's 3 here that I highlighted that are the major ones that we utilize a lot here in the West. And Jason and the Midwest, they also use the Agrolution pH low 114511 as a starter, and it has the 2% zinc. We use the 63131 throughout the season, and then we will apply nitrogen that the crop needs along with that. And we'll show you some examples of those when we look at these next set. And then we also have for when we need the nitrogen, the potassium, and the calcium, then we also have another version there with the 15627. So those are our 3 major ones that we would utilize. And here's a kind of a summary or set the stage a little bit for a few of the things that we have seen with the Agrolution pH low. We'll look at some examples on potato, corn, and soybean as far as some yield increases that we'll see. A huge nutrient use efficiency advantage that we will see. And then as Jason mentioned, then we have the benefits on the environment. In addition to that, we've seen when we fertigate and we do that precise application through the drip irrigation, then on pears and apples and cherries, then we can get a yield increase as well. And I'll show you some of the soil data to show you the big differences with the Agrolution pH low 63131. And then if you're after the vegetables, potatoes, you know, again, the strawberries, the 15627 is what we fertigate a lot for that precision and the nutrient use efficiency that comes with it. Okay, so I'm going to start with a potato example, and this particular potato example, looking at the marketable yield here on the y-axis, your control is the UTC, the 353 hundredweight per acre. The 10340 is a 349, and that was with 4 gallons per acre. So 4 gallons per acre of the 10340 would be equivalent to 15.8 pounds of P2O5. Then you look at the Agrolution pH low, we applied 12 pounds. And so when we have the 12 pounds of the 114511, it's only 5.4 pounds of actual P2O5. And then we also were trying to find the right rate, went up to the 18 pounds, and in this particular trial, the 18 pounds did not provide an advantage. So you look at that Agrolution pH low compared to the 10340, providing a better yield and better economics, better environmental footprint, and doing it with 3 times less P2O5. So if we look at some of the economics of that, and we go through some of it, and we would say, if we look at general numbers that we'll utilize here and some assumptions, and it's always going to vary up and down, but looking at what current prices would be for that extra 2200 weight that we would be getting, you'd be looking at $440 extra profit. And then there was only, you look at the difference in cost and subtract it out, for adding the Agrolution pH low compared to the 10340, we were still making $436 extra per acre for the grower in this case. So we had a triple win agronomically, environmentally, and economically. And that's really what we're after, is trying to find the ways that we can be more innovative and utilize the tools that are going to help us. This is another example looking at it from Michigan State University. You can see a similar sort of trend, that the Agrolution pH low increasing the overall yield. And this was, if you look at it, 79 pounds of P2O5 with the 10340 compared to only 22 pounds. So 1/3 the amount of phosphorus that had to be applied. So definite phosphorus use efficiency. Jason will show you more in depth on some corn trials, but I just kind of wanted to give you a general one looking at this grain corn yield, your control versus your 1034.0, and then the 6 pounds of the 1145.11 versus the 12 pounds. And you can see here where you have, only 2.7 P2O5 compared to 11.9. So again, highlighting that phosphorus use efficiency that we're getting with these products across the board in multiple different crops and multiple different locations. When we look at the precise fertigation and why we would want to be doing it, sometimes we have soils and water where we don't need to acidify the pH as much. Other times we definitely need to do it quite substantially. So the pH in this case was starting out at 7.9. And then when we added the pH low, it went down to 6.6. Done straight Novapec acid, it would have been a pH of 3 from that straight pec acid. So you can see here why we like to use the 631-31 when we're fertigating during the season for vegetable and fruit crops. It's an excellent source of making sure that we're lowering the pH right in that rhizosphere around the roots. So when we've done that, we've been able to have both on pears and on cherries, we've been able to have yield increases that have shown us a big advantage. We also can look at when it's needed. We put on, this is a foliar option, the Nova Pulse, that we won't delve into a lot today, but it is important to think about the whole balanced system and what the crop needs from that standpoint. So the Nova Pulse with the cobalt and moly in it, and it's a 064 plus zinc and magnesium. So it was really beneficial as well. When we look at the pears and putting on that Agrilution pH low 631-31, we actually put it on 9 times that we fertigated it. You can see the drip irrigation there on the right side. It was on the surface. And we had emitters next to the trees. So those 9 applications of 13 pounds per acre, if we added that all together, and we definitely saw a yield increase. But in addition to that, when we had those applications that we put on through the irrigation system, you can see here in the table on the left that the phosphorus and the potassium levels with the Agrilution pH low at the end of the season were almost double what it was of the control. And if you look at typically what we would have thought, we would have only raised the soil parts per million 2 to 3 parts per million for the P and the K. With that amount, we were only putting on 36 pounds of P2O5. So a substantial response that we're seeing there. Now this sampling is done only in the root zone to 8 inches along the tree line where it was fertigated. We're doing a precise application. We're not trying to do soil profile. We're only looking at that soil solution in the root zone where the nutrients can be taken up. The other thing that was interesting here, we have a harder time getting the calcium and the magnesium into the plants than we needed. You can see on the right that we actually reduced the calcium and the magnesium level in the soil for the pH low. So that means that it was becoming more available to the plant so that it could utilize it effectively. And you can see the economics of it that would come into play for this. You look at the growers and what it does for them. When we can significantly increase the yield, then it has a positive economic benefit. One less example on the fruit side. This one's looking at apples and what were we able to do. Again, it's Agrilution pH low 631-31. You see it on the right bar. We actually put on 3 applications, a total of 40 pounds to the acre. And the increase that you see there from the 928 up to 1,024, a 95 bushel, 95, 96 bushel increase. So you're looking at $4,300 per acre. And when you subtract off the cost of the products, we're looking at about $1,200 per acre, $1,220 per acre that we would have advantage economically for the grower. So whether we're looking whichever crops, we see the economic benefits coming into play there. So I'm going to turn it back over to Jason for a little bit.
Okay. Thank you, Christy. Thanks for that overview of some of the past trial results. And I think it's clear based on the examples that Christy shared from potatoes and corn and even tree fruits that this acidifying phosphorus technology has a broad applicability across many different crops, and not just the early season nutrition and starter fertilizer that we're primarily focusing on today, but has fit across different soil types and different crops in North America for this PEC acid-based technology. As we think more about early season nutrition and starter fertilizer applications, whether that's in furrow or some other placement method like 2x2, the other product category or product categories that often retailers and farmers think about or are increasingly thinking about are products like biostimulants and biologicals, inoculants, and other products that will term here enhanced nutrient fertilizers that have nutrients, but also other components that add a little bit something extra in terms of nutrient use efficiency or plant yield benefit. In other webinars, we've dove into this topic of biostimulants in greater detail, and our position is that biostimulants and biologicals and related types of products don't replace nutrition, but are an important tool to help make what we're already doing, the nutrient applications, even more efficient. And so how do they make nutrients more efficient? It really comes down to the impact that biostimulants and biologicals and other types of products have on plant physiology and soil microbial activity as well. We'll talk about Bio's Diamond as one example of a product that we've included in our starter fertilizer trials along with AgroSolution pH Low, and demonstrated very good results across a number of crops. But when we think about this combination, fertilizers provide nutrients, and how we can make those nutrients even better and more efficient is by considering the optimal combinations of again biostimulants, biologicals, or other related types of products with the nutrients that are so important for crop productivity, yield, and quality. Biostimulants are an area that is intense interest and research across the agricultural industry currently. And although the modes of action, mechanisms of action for biostimulants are not always fully understood, I think generally we can consider these products to enhance plant physiology or enhance plant stress tolerance. In some cases, may be impacting positively microbial life in the soil, and we'll talk more about the interaction of the plant and the rhizosphere and the microbial life in that rhizosphere here in a moment. And then ultimately, through that combination of directly impacting plant physiology or potentially impacting microbial life, the end goal in many cases is nutrient use efficiency or increased nutrient use efficiency. Soil health and the soil microbiome is another area that's a hot topic currently, and the soil and the life that the soil contains is so important for crop productivity, crop yield, and crop nutrient use efficiency. And much of that interaction between the plant and the soil microbiome occurs right at this interface between the root and the surrounding soil or the rhizosphere. We know that plants actively communicate with and support that microbial life in the rhizosphere, as an example, through the exudation of nutrient containing substances in that root zone. The secretion is regulated by plant nutrition and development, and through using biostimulants and biologicals in many cases, we're in some way or another modifying or improving this interaction that occurs in the root zone, either through stimulating additional root development or other maybe less well understood factors. As many on this call will likely recognize, there are many biostimulants and biologicals that can be applied at planting, either as a liquid addition to a starter application or as seed treatments. In many cases, these early season applications impact root development in a positive way, increasing root density or the formation of fibrous roots that help to ultimately improve nutrient uptake over the course of the season, but also improve other factors like water uptake and water use efficiency. And so, here's an example or a couple of examples, one on the left of how, different plant hormones impact root development. The interaction of auxin and root development is well understood and has been for many years. And then on the right side, there are some examples of how different levels of nutrients in the soil, phosphate, nitrate, ammonium, and potassium also can impact root development. So this speaks to the importance of early season nutrient placement and getting those key nutrients close to that developing root system, but also speaks to the importance of efficient nutrient use, whether that's through modification of pH in the case of agri-lucian pH low and pec acid for phosphate use efficiency, or other approaches that we might use to improve the efficiency of other nutrients. The product that we'll highlight in our starter fertilizer trials for corn, soybean, and potatoes is a product called Bio's Diamond, which we are currently selling in the United States, but had its origin in Brazil. This is a product that is rich in molasses and yeast extract, and so it doesn't meet the formal definition of a biostimulant, but has many of these carbon-rich compounds that positively impact the plant or activity occurring in the soil. And so, as an example of that soil impact, this is a study that measured 3 key enzymes from the soil: beta-glucosidase that involved in carbon cycling, phosphatase that's involved in phosphorus cycling, and then aryl sulfatase that's involved in sulfur cycling. And so, in each of these three, or for each of these 3 enzymes, you see a positive increase in enzymatic activity, where Bio's Diamond was applied to the soil across a broad range of crops in Brazil. So here's another example of a root pit where we have a control on the left with no additional products supplied other than the base nutrition. And then on the right side, we have a combination of Bio's Diamond, the product that we have here in the US now, along with another ICL biostimulant that's only available in Brazil at this point called Bio's Amber. And so again, you see the clear impact on root development from these early season at planting applications for enhancing root growth and ultimately plant nutrient use efficiency. So here's a few examples that tie together the concept of agri-lucian pH low that Christi introduced, as well as how we can make that better, or supplement that with a product like Bio's Diamond. And we've got examples from corn, soybeans, and potato. So here's an example of a corn in-furrow trial, and this is the one that Christi introduced briefly earlier, where we have what we're calling APP, ammonium polyphosphate. Many of you will recognize that as 1034O, applied at 3 gallons per acre. And so you think about 3 gallons per acre of 1034O, that's around 11.9, almost 12 pounds of P2O5 per acre. If we go a little bit further over to the 4th bar from the left, we have agri-lucian pH low, the 114511 analysis that Christi introduced, applied at 6 pounds of product per acre, solubilized into water. And so this rate would supply 2.7 pounds of P2O5 per acre. And then if we go over to the 6th bar from the left, we have agri-lucian pH low at 12 pounds per acre, which supplies 5.4 pounds of P2O5 per acre. So if we just consider these 3 treatments, we definitely have an increase in yield compared to the control, suggesting that this was a starter responsive environment. And really, similar response across the 3 treatments of around 4.5 to around 6 bushels per acre from the starter nutrition. But more importantly, we're getting that same response or similar response with rates of product that supply very different amounts of P2O5. Again, almost 12 pounds of P2O5 for 1034O, and then down to 2.7 pounds of P2O5 per acre with that lower rate of agri-lucian pH low. If we just consider the effect of Bio's Diamond by itself, that bar to the far right, the 8th bar, We did have a small increase in yield, numerical increase in yield of around 2.5 bushels per acre. But where we really see the benefit of this additive product on top of what the starter nutrition can provide is when we you supply agri-lucian pH low in combination with Bios Diamond, or for that matter, supplying Bios Diamond in combination with 1034O. These combination treatments are the third bar from the left, the fifth bar from the left, and the seventh bar from the left, where there's a clear benefit to adding Bios Diamond on top of the starter nutrition. And the highest yield and highest response was from that combination of the high rate of agri-lucian pH low at 12 pounds per acre of product, along with 1 quart per acre of Bios Diamond. Across 2 years in the same location. So the previous slide was the 2022 data, which I'm again showing here on the left side of the slide. But now we have the 2023 trial data on the right side of the slide. And very similar, if not identical, response or trend across both years of this trial, where we have similar or the same responses from 1034O and the 2 rates of agri-lucian pH low, even though they supply different amounts of phosphorus. And then when we combine with the starter fertilizer with Bios Diamond, we get an even greater response to that early season application, with the highest yield and the greatest response from the high rate of agri-lucian pH low, 12 pounds per acre, along with 1 quart per acre of Bios Diamond. In the case of soybeans, we did the same trial again in Wisconsin at the same general soil type as the corn trials, along with the same treatments. Again, comparing 1034O at 3 gallons per acre to the 2 rates of agri-lucian pH low with and without Bios Diamond. And so in this example for soybeans, we actually see that we do get a little bit of a response from 1034O on soybeans, which to me was surprising. Many would consider 1034O to be too high of a salt index for soybeans. But when we start to then switch to agri-lucian pH low, which would be treatments 4 and 6 in each of these data sets, we see a better yield increase for soybeans for an in-furrow starter application compared to 1034O. And we're just considering starter nutrition alone without the Bios Diamond. Highest response came from the 12 pound per acre rate of agri-lucian pH low, which would be treatment 6 in each of these slides. And then similar to the corn trial data that I showed, we do get a positive response from Bios Diamond by itself. That would be the dark blue bar, treatment 8 in each of these data sets. And then when we combine agri-lucian pH low with Bios Diamond, treatment 7, we have the highest overall yield and highest overall response in both of these years at this trial site. So that is corn and soybeans, and then I'll pass it back to Christi to talk about what we did in potatoes, which is very similar and a similar overall trend or response from compared to what we saw in corn and soybeans.
Thanks, Jason. Yeah, so I'm just going to let you guys look at the treatments. You follow them across, see what it is. And when you look at it overall, again, only 10% of the phosphorus that they had to apply compared to the grower standard when we put on the agri-lucian pH low, and still having a similar response. So a positive environmental benefit from that standpoint. And then when you look at the greatest yield response, it was very similar to what we saw with corn and soybeans in this location, that you actually had a combination of the pH low and the 1034O along with the Bios Diamond, resulting in the highest numerical yield there on the far right. So the Bios Diamond was put on at 1 quart per acre, and it ended up with a 4,000 weight per acre increase in the yield. So definitely an economic benefit when you look at the cost, not too much. Definitely seeing a positive economic advantage in that case. Okay, so another thing to look at is, here's another time where you look at 2023 and you say, well, let's compare sites. And we start off with the Whitewater, Wisconsin, Russet, Burbank, and we say, well, there wasn't any marketable yield increases. So then we're like, okay, well, we're done. Well, maybe not. What's the rest of the story? And then, we do see a yield increase when we look at a Manistee, a chipping variety in Michigan, and then North Dakota's a fresh market russet, and we see a statistical yield response as well. So those are a very clear economic advantage that comes across the board when you have those crops. But then when we start looking at what happens as far as the efficiency too, let's dig a little bit deeper into that Wisconsin site. So if we are putting on 1034.0 at 10 gallons per acre, that's almost 40 pounds of P2O5 compared to the 10 pounds of the Agrolution pH low 114511 with the 2% zinc, it's only 4.5. Big difference. Okay, so that's one piece to the story. So let's look at it from the standpoint of efficiency that goes with it. So if we have just the light blue bar would be your 1034.0. Your darker blue bar would be your Agrolution pH low, 114511. And you see that even though there wasn't a statistical yield advantage in this particular spot, we were actually 13 times more efficient with our phosphorus. And this is taking out the baseline control level. So that's the baseline fertility you can see there on the left, that third bullet down. We did take out the control out of there. So big efficiency advantage. You look at Marshall, Michigan, and the Manistee, 14%, 14 times more efficient, and then in the North Dakota, 11 times. So 11 to 14 times more efficient as far as the phosphorus. So that's a big win as far as looking at putting on less phosphorus and an environmental footprint that would come into play. And then if, like Jason mentioned, we're going to start with our baseline nutrition that we know, and we do our nutrient acquisition, we do our fertility that we know, and then we enhance it further with our Agrolution pH low, acidifying it, precise application, right fertilizer source. And then with potatoes, with corn and soybeans, where you look at the setup the same, where it has the 3 same locations. But when we put Bios Diamond in here, that's the one that is the dark blue bar is where you have Bios Diamond with the 1034.0, so it's 1.7 times more efficient. And then we knew that the Agrolution pH low by itself was efficient, 5.1 times more. But then when we add the Bios Diamond to it, we have 16 times the efficiency. So the Bios Diamond, whether we're looking at either source, was adding efficiency in there. And then you look at the numeric advantages that we see coming with the Manistee at 4.7 compared to 2.7 with just the 1034.0, and then 43% efficient when we put the Bios Diamond in. So definitely some advantages that we want to think through with combining what we've known in the past along with the next steps for our precision application. Okay. Jason?
Thank you, Christy, for showing those examples of increased phosphorus use efficiency. And I think it's important to kind of point out that there's many different ways, there's many different definitions for nutrient use efficiency, but fundamentally anything that we can do to increase crop yield, crop productivity without increasing the input of nutrients is an increase in nutrient use efficiency. And so in these examples where we're maintaining, or in many cases increasing crop yield with Agrolution pH low, either by itself or in combination with Bios Diamond, and at the same time reducing the amount of phosphorus actually provided as an input through the use of Agrolution pH low, is really driving these increases in phosphorus use efficiency that Christy showed. So to wrap things up, again, our focus today was on early season nutrition and getting ready for spring 2025, whether you're a corn grower or soybean grower, potato grower, or really any crop that benefits from early season nutrition. We talked about innovations in water-soluble fertilizer, particularly ICL's PEC acid product line and Agrolution pH low, and how this improves precision of nutrient use efficiency through combining these water-soluble fertilizers with early season banded applications, as well as the fertigation examples that Christi showed. Your nutrient use efficiency is the outcome, particularly for phosphorus through this modification of pH of phosphorus related from pH modification in either the water or the soil. We've talked about the impact of not only nutrition, but also other early season additives like biostimulants, biologicals, and our Bios Diamond product, and how that can impact root growth and nutrient acquisition. And ultimately, all of these things tie together to ideally reduce costs for the grower, but also reduce the environmental impact, especially as we think about nutrients like phosphorus and nitrogen that have greater scrutiny when it comes to environmental losses. In conclusion, we encourage you to learn more about ICL, and that can come about through a variety of different ways. ICL is active on Facebook, on LinkedIn. You can also reach out to Christi and I directly, or visit our website, which is icl-growing-solutions.us. So again, thank you to everyone who joined today, and I hope you had the opportunity to learn something that you can apply to your early season crop nutrition decisions in 2025.
And it looks like we have a few questions, so we can go ahead and dive into those. There appears to be good results using acetate forms and foliar fertilization. How would you compare the PEC acid formulation to acetate formulations?
That's a great question. We haven't specifically looked at that comparison of potassium acetate to PEC acid, and in the case of something like potassium acetate, clearly it has a broad range of applicability, not only soil application and foliar application, but with PEC acid, we're really only focused on soil application. With PEC acid being a very acidic product, it has in some cases been used as a foliar product, but there's a greater risk of crop injury from that low pH of PEC acid. Particularly considering some of the things that it might be tank mixed with for a foliar application. So if we're only focused on foliar application, potassium acetate has clearly been demonstrated to have great safety across a broad range of conditions for those foliar applications.
All right. Any trial work in potatoes with additional pH low applications at emergence and or tuber initiation?
Christi, you want to take this one?
Okay. So we regularly put Agrolution pH low or PEC acid, the Nova PEC acid straight, into our irrigation as far as fertigating it for the pivots when we put it on in season. So yes, we have definitely done it additional after that. As the crop needs it, we will put it on and fertigate them. And then depending on the soils, whether they're a higher pH or lower pH, if we want to mix it, we will sometimes do the high peak if we need a neutral pH, or we'll do the PEC acid if we need a more acidifying effect.
And to build on Christi's response, although not potato, we did also do a corn trial in 2024 where we included PEC acid as part of a side dress application in corn. So really targeting that side dress or wide drop timing for nitrogen, UAN specifically, but we also included a couple gallons of PEC acid solution, which would roughly equate to about 10 pounds of dry PEC acid per acre. And although we didn't cover that data here today, there was some quite remarkable responses from that in-season phosphorus and potassium nutrition that PEC acid contains. But also, I think some of the other factors that we didn't touch on in great detail today is that lowering of pH that PEC acid brings about in the soil also makes other nutrients like micronutrients more available to the plant, which could be contributing to some of the responses that we see from PEC acid or Agrolution pH low.
Yeah, and we've even seen on apples where we put it on the Novapec acid, and you'll see enhanced leader growth that will come from putting it on with apples.
Any data on orchard crops?
Yeah. So, we have some on the cherries, and we have pears that we've put it out on. We also have some on apples where we've put it out there as well. So positive benefits on all of them from the orchard standpoint.
Mm-hmm. And that is across a broad range of soil types as well. So in many cases, the trial work that Christi's led has been in the the Western United States and California and Pacific Northwest, but many of our apple trials have been in Michigan. So I think that kind of ties into the versatility of pec acid or agri-elution pH low. I think many look at this technology and the acidifying properties of pec acid and assume that maybe this isn't appropriate for soils that aren't high in pH, but in reality, many of the examples that we've showed today, the corn trials, the soybean trials, potato trials, and Wisconsin and Michigan, our apple experience in Michigan, using pec acid. I mean, these are all soils that are generally no higher than 7 in pH, generally between 6 and 7. But we've also used pec acid and agri-elution pH low in soils that are even a little more acidic in the range of maybe 5 to 6, and we still see positive benefits from using these products. I think part of the key thing to realize in that is that while we may have very large impacts on pH in water, water can have a high pH really all across the United States, but once that solution makes it to the soil, the impact on soil pH is much more tempered compared to what the effect might be in the water in which the water soluble fertilizer is being solubilized.
In your opinion, what are some of the reasons for inconsistent responses to biostimulants or carbon-rich amendments like Bio's Diamond?
That's a great question. I think anyone who's ever worked with a biostimulant or biological realizes that they don't always work, and this is a source of frustration for not only retailers but for farmers as well. And I think ultimately it comes down to understanding what that product is doing, either in the plant or in the soil environment, and specific to these carbon-rich amendments, or a product like Bio's Diamond that's rich in molasses and yeast extract. There's a lot of potential interactions that can occur with factors like soil organic matter, the overall environment, temperature, plant growth rate, the pre-existing availability of nutrients in the soil, and so that variability will exist across different years, environments, and soil types. And so our goal with the trials like what we've used as examples today for a product like Bio's Diamond is to really try to understand how it performs across a broad range of environments, so that we have confidence that we can pass along to our customers ultimately.
All right, this looks like it's the last question. In some trials, it looks like Bio's Diamond was applied at 1 quart per acre. Can or should it be applied at higher rates?
It can be applied at higher rates. In our in-furrow work that we've used as examples today, it was applied at a 1 quart per acre rate, which I think is in many cases a common use rate that retailers and farmers in North America are comfortable with and familiar with. However, I point out that this product that again originated in Brazil and has become a very successful product in the Brazilian market is used more as a broadcast soil broadcast applied product in Brazil, being applied before planting. And so in those cases, application rates could go a little bit higher just to ensure that there's adequate coverage and activity across the soil. And so in those examples, we might consider 2 quarts per acre for broadcast, and then for the use of a product like Bio's Diamond and fertigation applications where multiple applications could be occurring across the course of the growing season, it can certainly end up totaling more than 1 or 2 quarts, depending on how many times it's applied and the rate at which it's applied each time.
All right.
Yeah. The other thing that I would add to that Hillary, is that when we're looking at it now, we've been looking at some problem potato fields this year and how they did and what the performance was, and thinking about it for next year. And it's actually very sandy soils, and we're looking at trying to apply 2 quarts per acre because it's a sandy soil. You know, they've been trying to work on building the organic matter, but we really want to make sure that we have some good food for the microbes, and in helping there with being able to get our nutrients up into the plants and build a solid root system. So I think that you can go to some of the higher rates in certain circumstances. It justifies it from what we were looking at as well. So there's some definite advantages for those problem soils to increase it.
All right, that was the last question. So I would like to thank everyone for attending today's webinar. I especially want to thank ICL for presenting it, and a special thanks to our speakers, Christi and Jason, for providing valuable information about how water-soluble fertilizers and enhanced nutrient fertilizers are reshaping early season crop nutrition. If you want to watch the webinar on demand or revisit certain parts, it will be archived and available at the same link you used to access it today. You will also receive an email reminder of the archive with the link tomorrow. Thank you again for joining us. This concludes the webinar.